Hello grade 7 children. Today I am here to teach you your syllabus, grade 7 syllabus relevant to your textbook. So join with me, I'll teach you the whole syllabus. So what's the first topic in your syllabus? That's symmetry. So what is symmetry? Look at me. So when I take my this ear and this ear, the distance from nose to this one and here to here, what can you see? Both are equal. And also, if I take the distance from my feet to the ear, the height, and this side, what can you see? Both are equal. And if I draw a line along my nose and navel, I can see my left hand side is same as my right hand side. So that's called symmetry. But in this lesson, we are talking about bilateral symmetry. Bi means dividing into two parts. I am a symmetrical object, but we are talking only plane figures. So we'll see what are the shapes that you need to learn to see bilateral symmetry. Look at these objects, a Christmas tree. So we can see if you draw a line here, we can divide this figure into two equal parts. What about this butterfly? Can we draw a line to divide this into symmetrical parts? Yes, we can. So here, if we draw a line here, this side is same as this side. And also this leaf, if you can draw a line here, we can divide this into two equal parts. So these are symmetrical objects. Now look at this one. So this is a butterfly. So this is the same thing here. Look at the above butterfly. Look at the line AB drawn on the middle of the second figure. So this line. How many similar parts of butterfly have coincide from AB line above? We can see two equal parts are there. So we can write how many parts? How many parts are there? Two equal parts. Are both left and right sides equal in every way on the above figure? Yes, we can see everything on left hand side, on the right hand side as well. So yes, equal. What name can be given to a figure like the above? Symmetrical object, or you can say bilateral. Bilateral means divide into two equal parts. So I can write bilateral symmetrical object. Suggest a name to the AB line. So we can say this one is symmetric line or axis of symmetry. So you can use two names, symmetric line or axis of symmetry. So any figure having equal parts around an axis of symmetry is considered as a picture having bilateral symmetry. So this is a picture having bilateral symmetry. Look at this picture. So this is the first figure, same figure there, and there's a line AB. What is the name for AB line drawn on the second figure? We can see left hand side and right hand side both are the same. So AB is a symmetric line or axis of symmetry. Does the above figure have a bilateral symmetry? Bi means divide into two equal parts. Yes, you get bilateral symmetry. Most of the images that can be seen around the world have the bilateral symmetry. Flowers, you can see animals, human, and also leaves, trees. Trees sometimes you don't get bilateral symmetry, but leaves you get bilateral symmetry. An image is more beautiful because of the bilateral symmetry that makes the environment beautiful too. Write down the symmetric line or axis of symmetry of the above figure. So here we can see left hand side is the same as the right hand side. So what's the line? PQ line is the axis of symmetry. Write down the other points that lie on equal distances from the symmetric line. When you take B, what's the point on the other side? It's N. If you take C, this one. So what's the other point, equal distance point? M. D is here. What's the equal distance point? That's O. E, where's E? Here. So equal distance point is K. F, this is the point. Equal distance point is J. Let's take point G. What's the equal distance? That's I. So same figure is there. You are asked to write down more parts similar to the following parts of lines. AB, this line. So this line is same as AN. BC line, where's BC? This horizontal line. So that's same as MN. CD, it's the vertical line. That's same as MO. DE, this line. So that's same as OK. EF, this line. So that's same as KJ. FG is this vertical line, that's like JI. Name the part of the figure that is equal to the part of A, B, C, D, E, F, G, H, A. So that means this part. So if I highlight that one, A, B, B, C, C, D, and E, F, G, H, H, and A. So this figure, what's the other part? We can find other part as, what's the other part? A, N, N, M, then O, K, J, I, H, and then back to A. So that's the same part on the other side. So what are the letters we can write? A, N, M, O, K, J, I, H, again back to A. So that's the part same as to the other side. Draw symmetric axes on the figures given to the right side of the following figures. So here we have to draw the symmetric lines. We'll take dotted line. Okay, so what's the symmetric line here? We can draw from here to here. What about this figure? So starting from here to here, you get the symmetric line. What about the third diagram? Here to here. So that's the symmetric line. This flower, we can draw a line here. And can you see this way also? It's okay. We can divide this into two parts like this. And what about this one? You can divide this way as well. Then this line also possible. Divide into two equal parts. And also this line. So how many lines you are getting? 1, 2, 3, 4, 5. 5 lines. This shape, what's that? 1, 2, 3, 4, 5. 5-sided polygon, pentagon. You can draw a line here. What about this way? You can draw a line this way. Here. Here also you can divide into two equal parts. And here. So you get again 5 lines. This line also possible. So you get 5 lines, symmetric lines. Look at this one. You can only draw one line because of this part. You can't divide into two because this side is not the same as the upper part. This diagram. So you can divide exactly from here. That's the axis of symmetry. This one, we can draw a line like here. Can we draw a line this way? We can't. We can see this side is different to upper side. So you can't draw another line there. So that's the axis of symmetry. Take this diagram. You can draw a line. You can draw a line here. That's the line of symmetry. Axis of symmetry, symmetric line. What about this one? You can draw a line here. Can we draw another line? No, because this is different. So only one line. Underline the English capital letters without a bilateral symmetry. So we'll see what are the figures without. We can see here you get bilateral symmetry, but not here. What about this one? Not there. But H, yes, you get bilateral symmetry. Not in letter L. S, you can't divide here, so that's not bilateral symmetry. Here also, you can't draw a line of symmetry. V, you can draw a line of symmetry. P, you can't draw. R, you can't draw. E, you can draw one line there. J, you can't. Q also you can't because of this part. H, you get. X also you get bilateral symmetry. Complete the other part of the following figures by drawing it symmetrically. So shall we draw this? We have to draw the same part on the other side. So we can draw something like this. You can put the eyes like this and we can continue this part. I hope that your drawing is better than my drawing. You have to visually think what's the other shape and complete the diagram. What about this one? So you get one part here and the other part like this. This one you can draw something like this and is it symmetric? I hope that it's symmetric. So you draw with a ruler, take the ruler and you can measure this length and draw the other part. This one, can you draw? So something like this, and then here this is vertical, and again this one something like this, and this one, this side is vertical again. Here this one you get something like this here, and draw a line, vertical line, and then continue. This one, that's a rectangle like this, and then continue this part, and this circle comes here. And this one you draw something like this, a horizontal line, and then coming down and going up like this, and then a circle like this. Now we'll look at figures with several axes of symmetry. Some images have several bilateral symmetric axes. So look at this diagram. This is a square. So we'll see how many lines of symmetry are there. We can divide this into these two parts. And also we can draw a line here. A line here. And what about this way? Another line. And also diagonally we can draw another line here. So how many lines are there? 1, 2, 3, 4. There are 4. There are 4 axes of symmetry to a square. What is this shape? A rectangle. Now we'll see how many lines are there. Symmetrical lines. We can divide this into 2 parts like this. And also we can divide the rectangle into 2 parts like this. Can we draw a line here? You can't. Diagonally you can't draw the line. So how many lines are there? There are 2 axes of symmetry to a rectangle. This is a equilateral triangle. What is equilateral triangle means? All 3 sides are equal. So what are the symmetrical lines? I can draw a line here. And another line here. And the third line here. So I get 3 axes of symmetry there. So there are 3 axes of symmetry to an equilateral triangle. What's this? Regular hexagon. Hexagon means 6-sided polygon. Regular means all sides are equal. So how many symmetrical lines are there? We can draw a line here. Here 1, and then this way another one. Another one here. What about these lines? This is also possible. And this is also possible. So how many lines are there? 1, 2, 3, 4, 5, 6. 6 axes of symmetry for the regular. So this is important. Regular means all sides are equal. What about this shape? 1, 2, 3, 4, 5, a pentagon. But this is regular. Regular means all sides are equal. So we'll try to draw the axis of symmetry there. We can draw a line here. Another line this way. 2. This one 3. This one 4. And another line here 5. So how many lines are there? We get 5 axes of symmetry to a regular pentagon. Now this is a circle. A circle, how many symmetrical lines are there? So symmetrical lines you get here. You can draw another line here. This way also you can draw. And here you can draw another line like this. How many lines we can draw? Infinity number of lines, never ends. You can draw any number of lines. So we say a circle has infinity axis of symmetry. Infinity number axis of symmetry to a circle. Look at this figure, a cross. How many axes of symmetry are there for this cross? We can draw a line here, this way. What about this way? This way also possible. And also diagonally like this. So how many lines? You get 1, 2, 3, 4 lines are there. So there are 4 axes of symmetry to this figure. This one, you can draw a line here. This is not just a circle. So you get few axes of symmetry. This one is possible. And here also possible. This one also possible. So how many lines are there? 1, 2, 3, 4 axes of symmetry. This one, you can draw a line here and only here. So 2 axes of symmetry. What about this one? You can draw a line here and here. That's all. You can't draw another line. So that's 2 axes of symmetry to this figure. What about this one? You can draw a line here, here. Can we draw a line this way? No, this side is not the same. So you can't draw only 2 axes of symmetry there. This figure, how many axes of symmetry are there? You can draw a line here, this one. This way also you can draw another line, and this way another line. So how many lines are there? 1, 2, 3, 4. 4 axes of symmetry to this figure. Join the dots within the square rule sketch and draw a figure twice as big as the symmetric figure given below in the square rule sketch. So you have given a diagram. We need to draw the same thing but twice as this. So we can start here, this side 2 squares. So we can take 4, double of 2. 2 times 2, 4. You can connect here to here. How many squares are there? 1, 2, 3, 4. Here 2 squares, this side 4. Here to here 3 squares. So this way 6 squares. 1, 2, 3, 4, 5, 6. So this line. This side also 4 squares. 2 times 2, 4. And here above like 1 square. This is multiplied by 2. 2 squares. And here you need to connect these 2 lines. So that's the figure. Same shape but twice as this. 2 times bigger than this one. Now take a look at this one. So you need to draw this double as this one. So here 2 squares here, 2 squares there, 2 here and here. 1 down means 2 down. And here 2 squares here. And here 1 square up means 2 squares up. So here this is the position. Now take a look at this one. So this one, 1, 2, 3, 4. So you need 8 squares. 1, 2, 3, 4, 5, 6, 7, 8. So this is the square here. And this one, 1, 2, 3, 4, 5, 6. Here 1, 2, 3, double this, 6. So here you get this one and 2 diagonals like this, here and here. So that's the diagram. Double the size of this one. This one, 1 square each. So you have to take 2 squares. This one, 2, 2 here and then 2 down. Again here and here. So connect these dots. You can connect these dots like this. All the lengths are twice as the previous one. That's the diagram. This one, 2 squares here. So 4 squares this way. And 2 squares here. 2 squares here and here. and here just a horizontal line. Just a horizontal line here. See, what's the length? 1, 2, 3, 4, 5, 6, 7, 8 squares here. 4 squares. 4 times 2, 8. Looking at the figure below, fill in the blanks so that the figure is symmetric. So you have to take the whole figure. So what's the symmetric line? You can see PQ is a symmetric line. So this is the symmetric line overall. So PQ. PAB triangle. PAB triangle is this. PAB is this. So what's the other triangle? PGB or PBG. PBG triangle. BCD triangle. This one. BCD triangle. This one. So what's the other part? Equal part. BHD or BDH triangle. DEFQ square. DEFQ. That's not a square. That's a rectangle. Actually, this cannot be written as square. So that's a rectangle. So what's that? What's the other part? DQJI. DQJI. Other axis of symmetry of PABG, PAGB. If you take this as the whole diagram, what's the axis of symmetry there? One line is PB. What's the other line? Other line is AG. Other axis of symmetry of BCDH, BCDH, this whole diagram. What's the other axis of symmetry? We can draw a line here, that's CH. Now here an angle, ABC angle. ABC angle is this one. So what's the equal angle there on the other side? GBH. GBH angle. CDE angle. CDE angle. This small angle is same as this angle. HDI angle. Then APG. APG angle. So this angle is same as this angle, that's ABG. CBH angle. CBH angle. This one. This is same as we can write this angle. CDH. CDH angle. So understand in symmetrical figures, the size of angles and lengths are equal. So when you take the line of symmetry, so the lengths and all the angles in one side is equal to the other side. Write the axis of symmetry of the following figures. How many axes of symmetry? Look at the figure. You can draw here one line there, one axis of symmetry there. So what's that? AB line. This one, you can draw this line. So that's also AB line. That's the axis of symmetry. This one, we can draw the line other way around. So this line is the axis of symmetry now. So C, D. This curve also you get, this is the axis of symmetry, this is the axis of symmetry, that's CD. Complete the following figure so that the bilateral symmetry of them is sustained. Axis of symmetry is drawn with dotted lines. So here, this is the axis of symmetry drawn. So we need to complete the other side. I'll take from here. So here, how many squares? 1, 2, 3, 4, 5, 6. So you have to count this way 6. 1, 2, 3, 4, 5, 6. So this point. So you can connect here to here. Then how many squares down? 3 squares, 2 squares here down. So that means here, from here 3 squares. So this is the point. So you can connect from here and then 3 squares down and 2 squares down here, and from here how many squares? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this point. So that's the diagram. Complete the following figures so that the bilateral symmetry of them is sustained. Axis of symmetry is drawn with dotted line. So this is the dotted line. So starting from here, 3 squares this way, so 3 squares here. And here 3 squares down. So this line comes. Then, so you get, what's this one? So 3 squares this way. Now from here, now look at this one, 3 squares to this side, so 3 squares here. So this is the point. So you can connect here and here. That's the first part. And what about this way? From here, 3 squares. So this is the point. And then 3 squares towards this side. So you can connect this line and this one. And then 3 squares down. This is the point. You can draw the line here and then connect this line here. So this is the other side of the figure. Complete the following figures so that the bilateral symmetry of them is sustained. Axis of symmetry is drawn with dotted lines. This is the axis of symmetry. So now try to draw 1, 2, 3, 4, 5 squares here. 1, 2, 3, 4, 5 squares there. So this point. So you can first connect that one. Then here 3 squares. So this point. And here, how many squares here? You can connect with 3 points here. So 3 points there. And you can connect this triangle. Small one. This one, 1, 2, 3, 4. 1, 2, 3, 4. This point. And here, 1, 2, 3, 4, 5, 6, 7 squares. 1, 2, 3, 4, 5, 6, 7 squares here. So I can connect this point and this point. And then the horizontal line. So that's the other side of this figure. So this is the AF is the symmetric line. We'll draw the other side of this one. So this is the dotted line is the symmetrical line. So 2 squares here, 2 squares to the horizontal side. So here, this is this part. And here, from here, 1, 2, 3, 4. 1, 2, 3, 4. This is the point. And to this side, 1, 2, 3, 4, 5 squares here, so mark the point. And 2 squares up, that's the point here. And where's this point? 1, 2, 3, 4 points there. 1, 2, 3, 4. This is the other point. Now connect here to here. You can connect all these points like that. First, it's better to mark the points and then connect. So we can label the figure something U dash, P dash, Q dash, T dash here, S dash, and R dash. Look at this one. How can we draw the same thing? This is the line of symmetry. So we'll first mark the points. Here 1 square here, and here this point, and 2 squares and 2 squares up, and 1, 2, 3 squares to this side, and then how many squares this way? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this is the other point. And 3 squares down, 1, 2, 3, this one, and here 2 squares and 2 squares down, and 3 squares to this side. So this is the figure. So we can connect this one here. So connect all the points. That's the outer figure. Now we'll think about inside. You get a line here and a line there. And what else? It's shaded. So we can draw a line here and another line here and shade this part. So I can shade this with ash color, will do. This part and this part. So something like that. So that's the symmetrical figure to this axis of symmetry. Before we start to do the exercise, we'll see how we can cut a symmetrical figure. So you can take any colored paper. What you have to do? If you want one line of symmetry, what you have to do? You can fold the paper into 2 parts like this. You can fold this to 2 parts like this and squeeze this to get the axis of symmetry. So this is the line of symmetry. Then what you can do? You can cut any shape that you like. So you can cut any figure that you like. And when you take this one, what can you see? You get a figure with one axis of symmetry. So this side is same as this side. Now what about if you want 2 lines of symmetry? Then you have to fold it twice. So take a paper, then what you have to do? So you have to fold it twice now, not once. So you can fold it twice. So this is one line of symmetry. Then you can fold it again. So when you fold it again, you get the other axis of symmetry. So here you get 2 lines now. Now you can cut whatever the shape you like. Whatever the shape you like, and when you take this paper, what can you see? You get two lines of symmetry, axis of symmetry this way and this way. So you can create beautiful figures like this with several axes of symmetry. Now we'll look at exercise 1.1. From the following, choose the bilaterally symmetric figures with a correctly drawn axis of symmetry and write down the corresponding letters. So what are the correct figures here? We can say this is correct. So this is a line of symmetry. So we can write A. B, yes, this is line of symmetry. This side is same as the other side. Here, this one, see how many squares this way? 3. This is 3. So C also correct. D, you can see this part is not the same as this one. E, this is not the same as this side. So this side is bigger than that. This one, when you take this way, what can you see? You can't fold it. You are not getting this one, but this one, when you fold it like this, you get the same part. So G possible, and H also you get the same figure. So you need to fold along this axis of symmetry if you are getting the same side like the other one. So that means symmetrical. This one, no, you are not getting the same side. But this one, yes, we are getting the same thing. What about this one? Yes, same side. So K, and here, yeah, this is the line of symmetry. That's L. Cut out laminas of the following shapes using a tissue paper. Draw all the axes of symmetry of each of them. Paste all the figures having axis of symmetry in your exercise book. So you can do that. Cut all these figures and draw the axis of symmetry. I can draw here. Okay, so when you take this one, I can draw this line. This is the axis of symmetry. What about this one? We can see these two lengths are equal. So I can draw here and here. These two. This one, 1, 2, 3, 4, 5, 6, six-sided hexagon, regular hexagon. I can draw here, this way, here and here. And also I can connect these points also. This one here and this one there. So how many? How many lines of symmetry are there? Axis of symmetry? 1, 2, 3, 4, 5, 6. 6 axes of symmetry. What about this diagram? Only 1 axis of symmetry. You can divide into 2 parts like this. So only 1 axis of symmetry there. Cut laminas of the following shapes using paper. Draw all the axes of symmetry of each of them. A is a rectangular shape. B is a triangular shape with 2 sides of equal length. So now try to draw the axis of symmetry. I can draw a line here and here. You can cut it and fold this one. You get two axes of symmetry. This one, this is an isosceles triangle, two equal sides. So you can fold it like this. So one axis of symmetry. Write the number of axes of symmetry in each of the following figures. So A, you get two lines, and B, you get only one axis of symmetry. Create another symmetric figure by joining two figures of the shapes given in A and B above and paste it in your exercise book. So you can cut it and keep one on top of the other, but you need to remember that you get the symmetrical shape. So I did that for you. This is one way of pasting paper. So you have to paste these two figures, and where's the line of symmetry? You get here. So you can create several figures like this, but make sure the distance from here to here is the same. Question number 4. Write the statements below in your exercise book. Mark correct sign in front of the correct sentences and wrong sign in front of incorrect ones. In a bilateral symmetric figure, the two parts on either side of an axis of symmetry are equal in shape and in area. Yes, that's true. That's called bilateral symmetry. There are bilaterally symmetric figures having more than one axis of symmetry. Here's equilateral triangle 3. Square, you get 4. That's correct. The number of axes of symmetry in a circular lamina is greater than the number of axes of symmetry in a square. In a square, you get 4, but in a circle, you get infinity number of axes of symmetry. So that's greater. The maximum number of axes of symmetry in a bilaterally symmetric figure is 1. That's wrong. You can get more than 1. That's wrong. If a bilaterally symmetric figure which has at least 2 axes of symmetry is cut along one axis and divided into 2 equal parts, then each of these parts too will be bilaterally symmetric. That's true. So if you take we'll take something with 2 axes of symmetry, something like this. Now, if you take one side, one axis of symmetry this way, we can see this is also, you can divide into 2 equal parts. That's true. Example number 1. Complete the bilaterally symmetric figure such that the dotted line in the diagram is its axis of symmetry. The distance from A and B to the axis of symmetry is equal to the length of 3 squares. So here we need to complete this diagram. 1, 2, 3, 4 here. So you have to count 4 squares this way. 1, 2, 3, 4. Then to this side 1, 2, 3, 4, 5, 6. 1, 2, 3, 1 point and 3 squares here, another point. This one 3 squares and A point is there. Now we'll connect. You get a line here. So I'll use straight line here. You get a line here, here, You get line here. You can connect this here and here and this line. So this is the symmetric side of this one. So you can mark it with A dash here. This is B dash and here C dash and this is D dash. Exercise 1.2. Copy figure A in your square ruled exercise book. The dotted line indicates the axis of symmetry. Place a mirror on this line and observe the bilaterally symmetric figure. So you can do that. Take a mirror and see. Draw and complete the bilaterally symmetric figure. Repeat the above steps for figure B and complete the bilaterally symmetric figure. So we'll try to draw this. This is the line of symmetry. So you can complete this diagram. So here you can draw a line here, here, and then one line there. Then this way a line here and now connect this one. So this is letter M. So that's the figure. This one, letter I. 2 squares down, 2 squares down here, and then 2 squares to this side and 1 square down, and you can continue this and complete the diagram. So you get I letter there. Draw a bilaterally symmetric figure with the points marked on the grid as vertices and identify its axis of symmetry. So we'll connect this and see. This one here and here and here. So what's the axis of symmetry there? So we can draw the axis of symmetry this way. That's the axis of symmetry. Copy each of the following figures given below in your exercise book. Complete the figure so that you obtain a bilaterally symmetric figures in each case. So we have to copy this down. So we'll take the first one here. First one here. So 1, 2, 3, 4. 4 squares down. So if you take this one, 1, 2, 3, 4. 4 squares down. And then 2 squares to this side. So this is the figure. So we'll connect it. So we'll connect this here to here, here to here. And this is the line of symmetry. So what's the other side? You get 2 squares here and here. So this is the figure you get, and line of symmetry is this. That's the first one. Second one, we'll take a line here. Line here. That's the line of symmetry. Now we'll count and mark the points. 1 square up. So, and then here, how many squares this way? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Here, and 2 squares this way. You get this shape. And 2 squares up and connect this one. So that's one side. How can we draw the other part? So you can draw here and 3 squares down, 1, 2, 3 here. So this one connect here and 2 squares up and connect to this point. So that's the completed figure. Now take a look at the third one. 1, 2, 3, 4, 5, 6 squares are there. So we can start from here. 1. So how many squares here? 1, 2, 3, 4. 4 up. That's half of a square. So we'll take half of a square here and then 1, 2, 3, 4. 4 squares up. 1, 2, 3, 4 squares up here and then 1.5 squares this way and 2 squares up. 1, 2. You get this one and complete this figure. You get 1, 2 here and half of this and go down. Half of this and go down here and complete the figure. Now, what's the axis of symmetry? Axis of symmetry is this line. That's the third one. Look at the fourth one. So you need 4 squares here, 4 squares there. But here if you can't draw this way. So I'll take this one. 1, 2, 3, 4, 5, 6, 7, 8. Yes, I can draw the figure this way. 1, 2, 3, 4. So I'll draw the axis of symmetry this way. And here we'll take 2 squares here. So 2 squares to this side. So 2 squares to this side and here 1, 2, 1, 2. So 2 squares here. And then how many squares here? 1, 2, 3, 4. 1, 2, 3, 4. So 2 up. From here 2 up again. So you get here and here. That's the figure given. This figure given. So you can complete the, that's not the figure. So this one and 2 squares down. So this is the figure. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is the figure given. Now complete the other side. You need 2 squares here, 2 squares and then 2 down. Like this, 2 squares. And here this point and then connect here to here. So that's the completed figure. Look at this one. You need how many squares there? 1, 2, 3, 4, 5, 6 squares to one side. 1, 2, 3, 4, 5, 6. 1, 2, 3. How can we draw this one? I can draw it here. Here 1, 2, 3, 4, 5 squares. So I'll draw 1, 2, 3, 4, 5 here. And then this one I need this one up. 1, 2, 3, 4, 5. And here 1 square this way and then 2 squares to this side means 2 squares here. And now I can connect here to here. Now I can connect here to here. So you get same figure on the other side. So you get same side as this one. So those are the symmetrical figures that we can draw. Trace each of the figures given below on a tissue paper and copy them in your exercise book. So what you can do, you can trace it and you can keep on the other side and trace the other part. Now turn the tissue paper on the dotted line. So draw the other half of each of the figures to obtain bilaterally symmetric figures. So I'll try to draw the other part. So you have the tracing paper, so you keep on the other side and trace it. So here we'll try this one. So you get this and something like this, and here. My drawings are not perfect. You can draw like this. You can draw the line like this and here and connect. And we'll take a look at the next one. Draw 3 bilaterally symmetric figures on square ruled paper such that each figure has only one axis of symmetry. Draw the axis of symmetry of each of the above figures. So first we'll draw the axis of symmetry and then try to complete the diagram. Okay, so if this is the axis of symmetry, you can draw any figure that you like. You can start, you can draw one line here, something two, and here something like this, and then you draw the other side, 3 here, then this side 2 and this shape, and you can connect. So this is only one line of symmetry. Another one, you need one axis of symmetry. So first draw the axis of symmetry. I'll draw it here and then continue. This time I'll draw something like this. So here 3 squares here, 3 squares there. Somewhere here, something I'll connect like this. You can draw anything that you like. So I'll draw something like this here and something like here, and then connect to this point. So this is also a shape with one axis of symmetry. Another one, I'll take the axis of symmetry this way. And then I can draw anything I like. So I'll take, first I'll mark the points and see. So here 1, 3 and 1. So to this point 1 here, 1, 3. So this point. And then I'll mark these 2 points and this one and here. So I can connect like this. We'll try to draw a leaf or something. So I can draw like this and then here something like this. So this is a figure with one line of symmetry. Question number 6. Draw 2 bilaterally symmetric figures on a square ruled paper such that each figure has only 2 axes of symmetry. Draw the axis of symmetry of each figure. So we can start with first the 2 axes. We'll take this line and this line. And then we have to draw same thing on 4 sides. What can we do? We can take 1, 2, 3. Here 1, 2, 3. 1, 2, 3. And 1, 2, 3. Now we'll try to draw. I'll connect something like this and here this. So I have to do the same thing, no? This side should be the same. So if I take this side like this side should be the same, and I can connect these two sides. So this you can fold it like this as well as fold it like that. So you get the same shape. We'll take another one. So first draw the two lines. We'll draw one line here and another line there first. Those are the two axes of symmetry. Then you can draw the figure. We'll take one square up, one square down. 1, 2, 3, 4, 1, 2, 3, 4. So one square up, one square down. And two squares this way, two squares this way. One square up. So something like this. You have to draw the same thing on the other side. One square down here. You get this figure, and then so something like this. You can fold it either along this line or this line. You get the same shape. So we covered all theory related to bilateral symmetry. So what is bilateral symmetry means? When you fold a figure along a line, when you get same thing on the other side, we call that's bilateral symmetry. And what you call the line, that's called the axis of symmetry or the symmetric line. So you can cut different shapes with several bilateral symmetry.